Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to introduce what are called the trigonometric functions. Now the first thing to realize here is that the trigonometric functions are about right triangles. So I've got a picture of a right triangle here. This symbol here means 90-degree angle, which is what makes it a right triangle. I've called this angle theta, this angle alpha, this side A, B, and C. An important thing to realize, these labelings are completely arbitrary. You know, some textbooks use Greek letters to label angles, and that's what I'm used to. Some textbooks like to do something like, capital A for an angle and put a little a outside here for the side opposite or something like that. So, how these things are labeled really is not important. For right now, the important thing to realize is that this and this, these are both angles. Now, right triangles, right, any given angle within a right triangle has a set of what are called trigonometric functions that go with that angle. So the first one I'm going to talk about is what's called the sine function. And I've already written down how it's defined here. So sine theta, meaning the sine of this angle, is defined as, I put O over H here, this stands for opposite over hypotenuse. So if here's an angle theta, that is the side opposite. The longest of the three sides is the hypotenuse. So sine theta in this example is B over C. The cosine function is defined as the side adjacent over the hypotenuse. So in this example, this would be the side adjacent to theta. There's the hypotenuse. So in this example, cosine theta is A over C. And then the tangent function. The tangent of an angle theta is defined as the side opposite over the side adjacent. So in this example, this would be opposite theta. This is adjacent to theta. So tan theta would be B over A. All right. This is a short little mnemonic device, SOHCAHTOA, for remembering these. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, this video is just meant to be a quick introduction to these trig functions. One thing I'd like to point out, let's talk about the sine function, opposite over hypotenuse. And remember, this is the side opposite, this is the hypotenuse. The hypotenuse is always the longest of the three sides in a right triangle. Therefore, the sine function is always less than or equal to 1. Now, if you actually have a triangle, the sine function has to be basically strictly less than 1. The trig functions are defined a couple different ways. What I'm talking about now is the triangle definition of the trig functions. They're also defined in a coordinate plane on a circle radius r, and I'm going to just save that for another video. So sticking to within the triangle definition of the trig functions, the sine function is going to be less than 1. Same thing with the cosine function. The tangent function doesn't have that restriction. This thing really can take on about any positive value here, again, if we're sticking with the triangular definitions. Now, before I end the video here, just want to go through a quick little example here. So, oops. Here's some sort of triangle, and maybe this is an angle theta, and let's see, 3, 4, 5 is a real common ratio or set of legs, I guess, if you will, for a triangle. So with this given right triangle, sine theta would equal the side opposite over hypotenuse. That would be 4/5. Cosine theta would be the side adjacent to theta. That's the 3 divided by the 5. And then tan theta is the side opposite divided by the hypotenuse. So these ratios, 4/5, 3/5, and 4/3, give the sine of the angle theta, the cosine of the angle theta, and the tangent of the angle theta. So again, this video was just meant to be an introduction to the trig functions, and there they are. I think I'll save other videos for examples. Have a great day.